Hello, this is David Hall of the IoT M2M Council, or IMC, and it is my pleasure to welcome you all to track 3 of IoT Days Summer. This panel is titled Agentic AI Reaches the IoT Edge with Easy-to-Use Options. This event is brought to you by the IMC. Before we begin, we wanted to cover just a few housekeeping items. This webcast is being streamed through your computer, so there's no dial-in number. For the best audio quality, please make sure that your speakers or your headset are turned on and that the volume is up so that you can hear the presenters. An on-demand version of this webcast will be available later today and can be accessed using the same audience link that was sent to you earlier. Also, materials from the presenters will be available in the handouts section of the interface, so feel free to look at that and download some additional material there. If you have any questions during the webcast, you can submit them through the Q&A box on the right side of the screen. The presenters may answer questions throughout the session, but feel free to ask questions at any time as well during the presentations. Any unanswered questions may also be responded to offline as we keep a record of your question associated with your registration. For those of you that don't know the IMC, just a quick word of introduction. The IMC is the largest trade organization dedicated to the global IoT sector. Its membership is comprised of 28,000 adopter members who are individual enterprise users, product makers, and applications developers that deploy IoT solutions. The IMC Board of Governors includes over 25 of the most influential IoT technology companies that provide solutions for connecting remote devices in the form of hardware, software, and connectivity. We encourage anyone attending today to check out our website, iotm2mcouncil.org. On that website, you'll find information about the IMC's various activities and events, including as well in the area of IoT cybersecurity. Now, moving on to today's session, the mission of the IMC is to accelerate the adoption of IoT technology for the public good, and we look at today's session on AI at the IoT Edge as exactly in keeping with that mission. So now it's my pleasure to introduce to you Benson Chan, who's the co-founder and COO of Strategy of the Things Group, and he's going to be our moderator today. Benson, welcome.
Thank you, David. Good morning, good afternoon, and good evening, everyone, depending on where you're at. Thank you for attending this session. Today we're going to be talking about AI, right, and IoT. So, as you know, AI is everywhere, right? So everyone's talking about AI, everyone's doing AI. In fact, I was just talking to Rony. That's one of the only conversations they're having. Someone in Europe asked me, what's happening with IoT? Is IoT dead? No, IoT is really evolved. A lot of the data that IoT produces feeds feeds AI, right? So AI and IoT is just naturally have converged. IoT is even more important than ever, especially in the world of physical AI, robotics, and manufacturing and autonomous systems. So today, we're going to be talking about AI relative to IoT. What's the role of AI? What are some of the top use cases? What are some of the things that people are doing with AI? And how does someone go in and apply AI, especially at the edge, to their systems and operations? Today, I'm joined by 3 distinguished panelists. Rony Cohen, he's the co-founder and head of strategy and business development at FLOLIVE. There's joined by Z, who's the founder and chief evangelist at Aeris. Z was introduced to me once many years ago as someone who's forgotten more about the Internet of Things than most people know about the Internet of Things. So Z, welcome. And John Keever, CTO of IoT platforms at Telit, Cinterion. John's going to be sharing a lot of good insights as well. So with that, I'll introduce myself. Again, my name is Benson Chan. I'm the co-founder and the COO of Strategy of Things. So let me do this. Okay, so for the last 10 years, I've been working in IoT and working with, in the last couple of years with AI. We've been working on the adopter side and helping adopters adopt some of the latest emerging technologies, which is a challenge in itself. Right? It's not very easy. There's no standards to it. There's no best practices. There's a lot of barriers. So we help them bring that up. I've also been the head of the Federal IoT Advisory Board, appointed by the Secretary of Commerce under the Biden administration. We're helping the U.S. government drive IoT policy, as well as drive regulations and things like that to drive adoption within the U.S. Second thing, we were also received a federal grant a few years ago to identify areas of research that the federal government should be investing in to drive IoT adoption within the US, right? But from a technology perspective, what are some of the technology gaps? Now, one of the things that we mentioned in our research was that the federal government should be looking into AI, right? And so this was a couple of years ago that we turned in a report. And so a lot of the things that you're seeing and talking about today and AI is something that we mentioned earlier and is heading on. From a business perspective, AI is everywhere now. Everyone's talking about AI, everyone's trying to do AI. But what we're seeing in the early adopter community is that most of these efforts, while they have successful pilots, they haven't made the P&L impact yet. Right? So I listed a couple of statistics here. Right? And that's the reality. A lot of the projects that people are doing hasn't done a good job in scaling because, for example, the data infrastructures are there in a manufacturing environment. They're not able to get the data out. There's a lot of legacy equipment. Right? So that's one of the reasons why a lot of these efforts successful at the pilot level, but at the operationalization and scaling level, they haven't made that P&L impact. What we do is we work with clients and we help them, at least from a planning and governance perspective, we help them put some of the systems, controls, and the practices in place to allow those pilots to scale, allow them to be successful. We focused in 3 areas. One is assess their readiness for AI, right? which is, for a lot of people, is still early in the journey. Right? They don't know where the gaps are. What are some of the things that they should be looking at? We looked across 9 dimensions, from infrastructure, operations to the organization. Second thing that we do is we know a lot of people, especially in manufacturing and healthcare, they've got a lot of use cases, but they don't know which ones to go do. And it's not always that obvious because they may not necessarily have the infrastructure to support it, for example, right? So that's not necessarily a good use case to start. And then the third is we're looking at a lot of the market intelligence, what's really happening out there. AI is moving so fast. How do I make my investments and where do I make my investments? So one last bit, I'll shamelessly plug this. We've got a free AI readiness assessment. This is just 12 questions, 5 minutes complete. You get a free report afterwards, and you're able to also download the AI Impact Handbook that we created. So we're talking about AI, but where does AI fit in? And a lot of it is there's an evolution. When we started with AI and IoT, originally a lot of it was just looking at numerical data, sensor data, and it's machine learning, right? So you use machine learning, you look at predictive maintenance, you optimize machine use, for example, or you detect any product defects. But with the emergence of generative AI and agentic AI, all of a sudden you're looking at not just device level information, but you're looking at really enabling operations, AI enabled operations. Right? So this is where a lot of the physical AI starts to come in place. So for example, you take the same use case and you go and something's wrong with the machine, you're not really sure what it is. So using generative AI, you can look at the operator logs, you can look at the technical manuals, you can look at the manufacturing procedures, and you could use that along with sensor data to diagnose and plan what's going on. And then once you identify the root cause of something that's not operating right, you could then integrate and use agentic AI to go and execute on some of the recommendations, order the parts, reschedule the production line, schedule a technician, open up a trouble ticket, right? And so we move from looking at sensor data to really changing the way you operate, right? AI-enabled operations. So all of a sudden, IoT plays a much bigger role in a much larger picture in terms of operations. So that's kind of where we're seeing AI and IoT happening or evolving. Now, the problem is that, especially when it comes to agents, the real issue is, well, am I ready to do this? What are some of the things that I need to do? It's not simply a matter of getting data, running the AI, and doing and then getting the outcome. Sometimes the outcomes don't always appear, and we have 4 questions that we ask. Right, very simple. Right, where's the opportunity for AI? For AI agents within your operations today, right? So you have to kind of pick it. Now, sometimes people confuse agents with everything, right? There's automation agents, and you don't need a lot of reasoning, a lot of intelligence to do that. And then there's AI agents, which Agentic, which requires a lot more. You give a lot more freedom, right? So it can do reasoning, it can think through a lot of things, and contact other agents. So there's a lot more autonomy into that. This maps back into and I mentioned earlier, we look at it through 9 layers, but 3 dimensions: infrastructure, operations, and organization, right? So if that first question maps into the operations layer. Second question is, do you have the data infrastructure so that it guides your agent and your models, right? And that's layers 2 and 3, right, which is in the model and in the data part. And that's another common gap, especially in manufacturing, other environments where you may not necessarily have the data infrastructure to support what your AI needs. Right? So a lot of data infrastructure may not be there. Third question is your edge infrastructure set up to process AI? And that's part of the discussion that we'll have today. As the edge gets more powerful, as AI gets much more powerful, and the algorithms need more data, does your edge have the compute capabilities and storage capabilities to process this data? And then finally, when something goes wrong, who's accountable? Right? Especially when an agent does these things on their own. So that ties back into the governance and the organization dimensions of our framework. So this is a framework that we're using, a model, to look at the application of AI across the organization. But more importantly, as you're thinking of IoT applications, you got to think beyond the infrastructure into the operations as well as the organization. With that, if anyone has any questions, feel free to reach out. My information is included in this handout. With that, I'd like to introduce Rony Cohen. He's the founder and head of strategy and business development at FLOLIVE. Rony?
Thank you. Thank you very much. First of all, as a sort of a joke, I was kind of thinking to myself, who is responsible? You said, well, if the agent does something wrong, so I don't know who's responsible. I say blame the agent. Anyway, yes, thank you very much for having me, and thank you for this opportunity. I'll give you a little bit of background about who we are at FLOLIVE. For people who don't know us, we run the world's largest infrastructure, cellular infrastructure, with 40 core networks and 70 packet gateways and growing. So we serve the cellular IoT, mobile IoT world across the world. We have most of the operator groups part of our infrastructure, and so you can consume most of the mobile network IMSIs via our infrastructure. We have a full stack of from packet gateways to real-time billing, multi-level connectivity management platform. That's kind of a little bit of a background about who we are. And And I guess that leads us to the conversation of today's sort of agentic AI reaches the IoT edge. So I saw this quote recently, I think it's Gartner's, that it's 1,600 times more complex to train physical AI than machine AI in servers, or what we're used to in the LLMs. And I think that this sort of leads us to where this connects with our world, with the world of physical AI. So I think where it touches the world of IoT, it means that we are now reaching physical AI connectivity, and we need to serve that. And that means various things. The network is completely different, and in the sense that we now have to serve connectivity that the devices need anyway to their management platform, but we also need to serve their models. We are already working with several large enterprise customers from the automotive space, from the payment space, from the robotic space, some of the humanoid robots, some of the industrial robot machinery. And we're seeing that these devices really are, in a sense, the manufacturers still don't know, because almost connectivity was left to the end. That question sort of was realized at the end. Do I really need to think of my connectivity in the world of AI? So there's various aspects which I'd like to sort of touch on. One of them is, first of all, I'll touch on the regulation side. There's data sovereignty around AI. And I think, we don't have enough time to cover this, but certain sectors, certain countries, geographies have regulations around the data sovereignty. So data can't be transversed around the world in different sectors and different geographies. But then there's also the needs of the actual AI models running at the edge. And I guess that will become more efficient in the future. But at the moment, what we see is that the AI models running at the edge will call up the network and call up an intelligent AI, ready for AI network. That's what we're building now and we're launching, is to say to the network, I need a secure connection. I don't want to say VPN or not, a secure connection for the next 30 seconds, and I'm going to be sending this amount of data to my model and receive an update. And it's completely different from its connectivity management platform that's managing the device itself on a day-to-day basis. So that's kind of the first part of it. Then there's the second part of all of this, and I have the map in front of you so you can see, these are some of our examples of some of our locations around the world where we have packet gateways. When we talk about sort of data sovereignty and speed, the localization of the packet gateways, that having packet gateways all around the world means that we can provide a high performance network, meaning the lowest latency, localized IP addresses, data sovereignty, and obviously answering a lot of those questions and previously about roaming and issues like that. So I think it gives the example here, but I won't touch about that. But the real-time billing comes into place because all the infrastructure that we have is our own, and the packet gateways means that we are the ISP in every packet gateway that we own around the world, meaning that you get real, when I say real time billing. So it's up to the kilobyte, and it's up to the second. There's one more aspect I'd like to touch on, that is the inference point. And as such, every node around the world is obviously sits in also in cloud environments, but we could bring the inference point to where the customer has its inference point. So if your inference point is on AWS in a specific location, we could locate the packet gateway there for that customer, for that enterprise, in order to reduce that time, reduce that latency, bring down those software updates. I'll just give a little bit of an example about sort of, give the flavor about the 4 building blocks of it. It's basically, it's always unlimited coverage. Obviously saying a single SIM is a bit cliche because everybody would say that, but obviously it runs on a single SIM environment with a multi-IMSI application running on as a single profile on, and potentially on SGP32 if our customers needs that. And that switching mechanism between that with sort of business logic as needed. The localized termination is what we're discussing sort of on the infrastructure side, and that's where we're providing a high performance network. And the central management, obviously, from an enterprise point of view, the main key point is to manage all of this from a single, a single agreement, a single pane of glass, and infer a single policy all across the network. So in most cases, the biggest challenges of our customers is that they couldn't really enforce a policy, whether it was a security policy or sort of a data policy, because the networks that they were roaming, they didn't control them, and the roaming networks, they couldn't really infer any policies on those roaming networks. And they really didn't know what's happening on the other side. They could control it on the host, network that gave them the IMSI, but they couldn't do it further than that. So we are providing that across the board, and that autonomous adaptability is sort of now adding capabilities, such as route shifting. So if we want to shift routes between certain routing plans, if you have a data that you don't want it to be routed through certain areas of the world, that you can, if you want your data to stay local or stay in one groups, we could do that as well. And that's sort of what I was talking about before as well on the demands of the agents. That's kind of a background about where we are, and I'd say in the last sort of closing words, I'd say that what we're seeing is a completely different world of connectivity. We're seeing that you're going to be buying connectivity like you're buying the compute, because you're going to have to have them entwined. We see vast amounts of AI requirements, even if they're starting off slowly. Anything from a coffee machine that was maybe was automated before and had connectivity, now it's aware as well. Now it's aware, it knows. I've seen one example where it knows the humidity, and it knows me, and it sees that it sees facial recognition, it knows the time, and it knows what beans are inside it. But it also sort of decides that by the seasons and by the hour outside. So all these things are a lot more sophisticated, and that machine might need to only download updates maybe twice a year, but other machine would be download updates once an hour. And as such, you need the connectivity, the CDN closer to the packet gateway for use cases like that. I guess that's it for me for the slide. Does that cover it?
Thank you, Rony. Z, I'd like to introduce Z. Z, if you could introduce yourself.
Sure, sure, will do. I am one of the founders and currently the chief evangelist at Aeris Communications. Ran engineering and operations for many years till I moved into my current role, which is more external focused, essentially. Today, I'm going to give you a little bit of information about who we are as a company. I mean, I wish I had Rony's slides in front of me, because I think we have a lot of commonality, not surprisingly. At the present time, we've been in existence for about 31, 32 years. And as you can probably tell from the white hairs on my chin, it has been an interesting ride. I'll tell you that. IoT has been a very interesting, impactful technology on the entire world. We currently serve about 8,000 enterprises globally around the world with 110 million cellular devices. These are distributed in over 190, 200 countries. And of course, the services are available through a variety of different local carriers, as as we will see on that upper left-hand side. While we have 30 tier 1 MNOs that we provide services for, in the sense that their IoT capability is based on what we provide, we have relationships with over 600, 650 MNOs around the world to provide these services. We got into eSIMs pretty early, so we have about 41 million eSIMs out there today. Not surprisingly, auto constitutes a large majority of the applications on our network because cellular is a natural for connected car applications. We have 700 people distributed around the world, so providing services to those 8,000 enterprises. Bottom left gives you a little bit of a distribution of the typical applications that are running on our network. We've been growing very steadily over the years, 50% growth rate over the past few years. I don't have the latest facts for 2025 in front of me, but the numbers are very similar. And in terms of the key customers and partners that we have, car companies, not surprisingly, VW and Mitsubishi have been on our network for quite a while. And then our partners are, generally speaking, the carriers that we provide services to, as well as the people that we use for our own services for these enterprise customers. So that's sort of in a nutshell who we are. In terms of availability of services, literally around the world, more than 190, 200 countries, give or take a few regions, you can find our devices have been deployed for a variety of different applications, all cellular, in some countries 2G, 3G, 4G, in some countries in 5G networks as well. That's been our mainstay for a long, long time. Now, let me sort of give you the bullet points that I would like to talk about from a agentic AI at the edge perspective. Obviously, people are deploying units that will provide data where they can do analysis at the server or at the application, but I'm focusing my slide here at why the edge, right? That's the important point over here. First point, most important point, the volume of data and the increase in the number of devices is absolutely driving the need for having edge AI processing for a variety of different reasons, one of which is connectivity costs. You don't want to send everything back to a central server. And of course, the response times necessary for certain applications that matter. You see all of these growth predictions from the analysts that talk about billions of units, and great, we have to support that. We have to make sure that we can get the analysis done at the edge if the application is capable, so that we can reduce cost, potentially connectivity cost. And of course, that is a key driving factor in many cases for why people are considering edge AI devices that are out there. Autonomous, when you have a requirement for very low latency, then another reason why you may want to have processing right at the edge, in particular smart processing that uses AI techniques rather than just generalized functions that respond to certain kind of environmental events. Frankly, as you will see from one of the downloads that you can get in the handout section, autonomous IoT is the future. You expect devices to operate on the data locally, very locally to the application requirements, and therefore agentic AI, in other words, processing the data at the edge, is going to be a very key aspect of deploying these kinds of applications. Now, I always want to emphasize that I would want to use agentic actions very carefully. If you have an application that is automated and takes certain actions based on its understanding of the data that it received, don't cause harm. I think that human oversight can be important in certain applications. If it's if it's a sensor on the wall, or if it's a application that's transmitting data from an environment where perhaps the device has been taken over by a malware and you want to shut it off, great, do it. But be careful about harming people, because if it's a medical device, you want to make sure that there's a decision-making process, that the agent is not the responsible, the agentic AI is not the one responsible for taking the action, that there was human oversight where somebody could think through the ramifications of an action. Device capability fundamentally matters. If I have a sensor on the wall, it's certainly not going to have the processing power, the memory, or the ability to maintain any kind of a small language model right there at the edge. But if it's a gateway or has a significant amount of performance availability, then you can implement these AI techniques. Clearly, they're going to need to have some kind of a small model at the edge, which has been updated potentially from a server. where you have all of the large language models that can provide the necessary information. So what does that mean? The implication is that you must be able to have the devices be configured with those small language models. They must be able to connect to a server periodically and get an update, because you don't want an action being taken on data that is no longer relevant or valid. And of course, depending on the environment, a device operating in one country may be quite different from the same device operating in another country. You must be able to configure it for the local environment, the local requirements for the AI processing to occur. What that drives you to saying is that the OTA updates are absolutely essential. There was a time 15, 20 years ago when I used to say that OTA was a nice to have. Today, essential. You have to have it, because if you're going to implement any kind of a smart device, any kind of processing that is local and that needs to be configured and updated, you must properly orchestrate the downloads necessary for the firmware, for the language models, etc. Underscoring that, underpinning that, is to test your OTA thoroughly. The last thing you want is to brick a device because you got a bad OTA update and all of a sudden now you have to do a truck roll, expensive truck roll, to go repair something that went out of operational capability. Just don't want to do that. And of course, when you have the smarter the devices that are out there, not surprisingly, IoT security is no longer a nice to have either, it's mandatory. The techniques that everyone identifies and talks about, secure by design, make sure that you've implemented all the best practices for that class of applications. That makes sense. Secure by default, enable it. We have seen too many companies implement the reasonably secure design aspect into their application, but forget to turn it on or not turn it on in a way that is meaningful for the application to be deployed properly. There's a new term that I heard recently a few years ago: secure by demand, meaning that your customers who are deploying these units out there for their needs are going to say, is it secure? And regulatory environments today demand that the IoT security is present and you can get information to and from the device in a manner that prevents malware or prevents an attacker from gaining control in a highly capable device that could impact the entire world, let alone just the localized environment that it operates in. We have seen too many examples of IoT devices that have been taken over and impacted the internet and companies on the internet. So it's more important than ever. My final slide is just the information on how to reach me. There's my email address and my phone number. And of course, I would encourage people to download these slides so they would have access to it. It's in the handout section. And in particular, I want to emphasize that we have a new report that just came out. It's called the State of IoT. I was one of the authors on that paper, the State of IoT 2026 and beyond. And the reason I want to emphasize the word "and beyond" is because I see too many reports that either focus what happened last year or what are making relatively safe predictions as to what might happen in the next year or so. I felt given the experiences that Aeris has had over the years and also how excited I still remain about IoT, that I wanted to focus on what could happen 1, 2, 5 years down the road. So a significant portion of that report is dedicated to predictions. Some will come true, some will not. Let's see what happens. And I have no worries about being able to make those kinds of predictions, because if it doesn't happen in my lifetime, maybe it'll happen someday. That's pretty much it, Benson. Thank you very much for the opportunity here.
Okay, thank you, Z. John, CTO of Telit, Cinterion, take it away.
Thank you, Benson. Much appreciated. As Benson said, I'm John Keever, CTO of IoT Platforms for Telit Cinterion. I've been in the domain going on 40 years. 20 years with IBM and the concept of computer integrated manufacturing, and then moving out into the world of machine to machine and expanding that through 13 years as a company known as Evangelist Technology, where we're doing manufacturing automation, but also what led to the IoT domain and then the acquisition by Telit back in 2013 to bring the cloud platform and all in place. So been in the domain for a while, seen a lot of evolution, and very excited about kind of where we are at an inflection point as AI starts to find its way to all levels within that end-to-end infrastructure that we support. So talk a little bit about Telit Cinterion to start with, just positioning here from the corporate perspective, for kind of main lines of business. If you take a look at it, upwards of 500 million connected devices out there that we've enabled, over 12 million SIMs activated in our connectivity domain. And if you take a look at outside of the Chinese market and automotive and kind of the PC domain, around 16% market share. So very active in the connectivity and enablement domain. If you take a look at our IoT modules, they span everything from 5G, 4G, low power wide area, location, as well as Wi-Fi and Bluetooth. So lots of capabilities to connect there, supporting manufacturers of devices of all kinds. If you kind of look at the lower level of the slide, everything from smart buildings to smart homes, healthcare, agriculture along the way, our modules end up in all of those types of devices, providing that first inch of connection, if you will, where it physically gets onto a network so that it can be transferred or operated with. Our solutions group takes it another step forward, where we can do industry-focused solutions, take the technology that we develop in the modules and then apply that to specific applications. Maybe you need a specialty device, in the healthcare domain. Maybe you need some specialty device, for smart city or what have you. But the ability to roll up our sleeves, provide, kind of a scalable regulatory activity and support you from a hardware and software perspective. Our IoT connectivity group, very focused on global connectivity, the ability to, have that SIM be able to transparently roam effectively across networks as needed, and to be able to keep, as a high level of integrity connection as you can, on a localized or global basis. So that's kind of the IoT connectivity section of the business. And finally, what we call IoT platforms, which is closer to what I live on a day in and day out basis, where we're focused on not only the software platform. I know multiple people, Rony, Zaeem, both mentioned the importance of over the air and what we refer to as device management, the ability to have a platform that supports effective device management, because you don't want to leave home without it. Otherwise, especially in today's world, as you're starting to leverage things more and more at the edge. But a lot of work we do is inside manufacturing. Automation is one of our kind of specialties, a little bit different than the standard end-to-end, where you're looking at an edge-oriented mobile device, but physically going into plants and doing the integration downstream into the controls and all the different types of devices downstream, as well as the upstream integration to manufacturing execution and enterprise resource planning, and kind of bridging that gap, but also now how we're introducing AI into that as a meaningful part of that equation. But supporting the types of things that allow manufacturers to manufacture. I mean, I used to love Telit's tagline that was "Making Machines Talk," and you've got 30 years in the business here of not only making machines talk, but making sense out of what they're saying. And that's a large part of what we try to do. Due to our history in the domain, our customer base includes over 30 Fortune 100 customers in the manufacturing domain. And some of the interesting discussion that's come from other panelists here this morning has also, referenced the concept of the fact that you need to be thinking about your infrastructure. You need to be thinking about what's there, and you can't just go dive into the world of AI as a point solution. It's going to require an infrastructure that supports it, whether it's at a connectivity layer, a database layer, an analytics layer. There's lots of pieces that come together as we start to lay the groundwork for this. The old saying, Lewis Carroll and Alice in Wonderland, with the Cheshire Cat discussion, said, when you don't know where you're going, any road will get you there. And that's probably not a good recipe when you start down the path here. What I wanted to do, and I think all of us, interestingly enough, have kind of referred to physical AI. When you're looking at, agentic processing at the edge, that's pretty much where the rubber meets the road. You're getting into physical AI, one of the largest domains of data that you can get into. And we know that data is the lifeblood of AI, so it's critical. But once you get into that, being able able to handle the high volume of events, whether you're doing video streaming, time series, data streams, all of this kind of activity, it has to be dealt with and effectively. And that's where critical infrastructure comes in, as well as, security. You can't just be casually moving data around in domains and not have it secure. Root cause analysis, if you don't have the correct, reasoning and the models that you need to apply to it, you're probably not going to get an effective answer out of it. And then it just kind of grows from there. You take a look at quality and safety decisions. You have to have, explainable workflows, whether they're tied downstream to a device, upstream to a process, and really all of the above. And when you, depending on what layer you sit at within this decision-making processing, applying agentic AI, where it's at the very edge, or it's upstream where you have a broader scope of what you have to analyze, you have to be able to make those quality decisions, or the old classic garbage in, garbage out model is going to, come to haunt you. Generation of custom models. When we first got into the AI domain about 5-6 years ago, very focused on visual inspection, we were creating our own models, our own model builders and things of that nature. But what we've come to realize is that if this is really going to go to market and spread and take root and grow at an effective rate, we need to leverage pre-built models as much as we can. It reduces the complexity, for customers. A lot of customers, this is where they get tied up in their own deployments when they get started, is the fact that generating an effective model and taking into, account all of the things, whether it's something as simple as lighting, temperature, all of those things that come into play when you actually deploy in the real world. And then that's where I think the thesis statement about being able to have a standardized stack to simplify the complexities is very important. So that was kind of, what I first wanted to connote. I will, take a moment here and talk a little about, how things tie together. And I'm going to kind of execute this from the top down, if you will, from our intelligence suite offering, which is very focused on agentic AI and what we call industrial agents. And it's a very purpose optimized agents. We're not out trying to do general purpose things. We're very focused on specific things in the manufacturing domain. And this, of course, can be, within that four walls, running there, or it can be at a cloud level and supporting data coming in. But first off, in this context of manufacturing, is more operational data and IT data. Depending on what you're looking at inferring, you're going to not only need data maybe from the shop floor, but you may need data from the enterprise system, enterprise resource planning or MES system. So you've got to have those hooks in both directions. And what we've matured to over the last several years is this whole concept of a kind of a virtual LLM, a large language model that's virtualized, because we can use pre-built models with lots of different perspectives, the concept of standard operating procedures and things like that. So you can effectively start, using, cameras as sensors in very specific ways within manufacturing. One of our features is Workstation Sentinel, and that's all about watching a workstation and, is a part fed incorrectly? Is it the wrong part? Is there a human in the way of a piece of moving equipment or rotating equipment that needs to be suspended? So all of these types of things that before we'd be looking at many different sensory inputs, digitally, now you're starting to be able to do that through AI. And optimization of processes, the ability to reduce downtime by being able to very quickly autonomously recover from faults and things of that nature are all part of the models that we're bringing forward in our intelligence suite. Because at the end of the day, we have this unified knowledge and data layer that we expose that allows interaction at all levels. Constituents could be operators on the shop floor. They could be, supervisors. They could be, management overlooking multiple plant locations. But the ability to tie all of this together in a unified fashion is what it's all about for us. But I think that the whole concept of standardized edge stack is going to be a critical part of moving forward successfully and growing the acceptance of AI. So, Benson, I'll hand it back over to you, and we can get started in the panel.
Okay. Thank you, John. Welcome, everyone. Welcome back. I'll kick off the panel part of the discussion with I'll combine a couple of questions. Why Edge AI now? Edge has been talked about for a long time, and there's been a lot of applications. And what are some of the top use cases that you're seeing out there? With that, maybe I think Rony, I'll start with you.
I think why Edge AI? I think it's because AI, sort of physical AI, has come into our lives, and I think that's the natural extension to the AI on our browser is really AI sort of assisting within our lives, in our factories, in our homes, in our hospitals, and I think that the at this stage we now have to take AI to the edge. I think, like Z was saying, what do we send to the edge? What do we send what we process to the edge, and what we process in the cloud? I think from our point of view, I think it's not exclusive, but this is why it's now on one hand. On the other hand, it's very different from what we've ever seen before. The machines now have this awareness, apart from sort of machine learning that we perhaps had before. They now have this awareness, and they will require us to be constantly connected, which is completely different from what we had in the past. A machine was autonomous; it always made you coffee. You pressed a button. I think now, these machines will be a lot more aware about what's happening around them, and they'll be consistently assisting us, in our activities. And this is exactly where physical AI comes into our lives, and this is, it matches Edge AI.
I think I'd build on. Do you want to go ahead with Z, or do you want me to?
Go for it, John.
No, I'm building on what Rony said. I just thought about the fact that another dimension to this is what's changed in the physical hardware at the edge too. I mean, as the hardware has become, much more powerful. We've got NPUs in the hardware. You've got Linux stacks in the hardware. It allows you to leverage that edge device in a way that you weren't necessarily able to do in the past. And also, clearly fundamental control theories, you always want to move the decision as close to the source point as possible. So the ability to now move things down into that, what we call the extreme edge device, and leverage maybe a neural processing unit for vector optimization, for the inference, allows you a solution set you've never really had access to before. So I think that's important. It also, of course, takes out the classic latency and bandwidth challenges that we have. And that's just one thing I'd add. So.
Yeah, Benson, I'm in vehement agreement with everybody here, I guess. I guess the real point to be mentioned also is that there are applications for which Edge AI just makes the application better. Now, I use that term kind of generally and vaguely, but the fact is that what we used to rely on control systems, as John pointed out, were evolving and changing. And now you may have a new need, new data, new information that may make life a little bit more easy, if you will. And I call it life easy for the smart devices out there to perform these kinds of actions that are meaningful. I always like to talk in terms of use cases. So I'm going to make one comment about, I did a recent count of how many devices I have in my home that are connected. I have 24 different connected devices in my home. Some are extremely simple, and some, like surprisingly, we used to lose food in our refrigerator all the time because someone might leave the door open. Now my refrigerator tells me if the door's been left open. Will it take eventual action to perhaps shut the door? I'd love to see that. I think that would be a one step beyond where we are today. But I think that's a physical action that just doesn't happen today. But little things like that. We have a water leak detection system because we once had a water leak in our house that caused some significant damage requiring a repair to a second floor ceiling. Wow. I mean, if I'd had notification and now this is a new system that I'm about to put in place, it'll turn off the water at the valve at the main entry point to the house. That's the kind of stuff that are simple actions, but is AI related to that? Not quite. I think we need to think about the fact that those are still point applications and point responses that people have implemented in IoT devices. And the next step beyond that is, what's the data coming in that is different from what I've encountered before, and therefore do I need to take some kind of a different action? That's when the complexity of the device and the complexity of the application starts becoming more meaningful. Connected cars are a good example of that. If I have a car that's driving from one point on the highway to another point on a highway with limited access, I'm less concerned about what might happen to that car than I might be in a autonomous vehicle that's operating in a dense urban environment and a pedestrian steps in front of me. That's the kind of stuff that I think we're still evolving. We're still learning about what is possible and what training and necessary information will be available to those devices for unusual corner cases which have not been encountered before. That's where I think the power of AI will come in at the edge. Not just what we think will happen, we as human beings implementing that application, but what the device encounters in the environment, what new data it gathers that might be meaningful for taking some kind of an action. And again, I just want to make sure that we apply agentic AI with care. Actions have to be consistent with the needs of the application and avoid harming people, because ultimately that's where we need to see the benefits of AI and not the dangers that could occur if we're not careful.
Thank you, Z. Yeah, one of the things that we saw, maybe it was last year, we went to an AI hardware infrastructure conference, and the thing that struck me was there were all these chip manufacturers and players, and they were all in the game. Everyone was in the game, and I realized they can't afford not to be in the game. Right? If you're not doing something for AI, you're out of business in 2 years, right? Because there's so many, not everyone's going to survive. But if you're in the game and you're doing something, you may survive for 5 to 10 years. There's no guarantee you survive, but they have no option but to play, right? So
if I might interject,
they have to.
I apologize, Benson. If I might interject and add one more comment, your point about the processor capabilities is absolutely critical and vital over here. 15 years ago, the processors that were out there may not have been sufficiently powerful to implement AI techniques. Now they are. And companies like Telit and John's company are in the middle of trying to understand what chipsets can do for edge processing that will make sense for them to deploy in the hardware that is being used out there in the radio modules, etc.
Mm-hmm. How do you guys, in fact, I'm looking at a question or a comment that came in, and it's edge IoT or low power devices. It's in the past, right? That's the case. Are you seeing that as the devices get much more powerful, that the use cases have changed, applications have changed?
Yeah, maybe I can start this time. And I think the point that is being made about low power devices is absolutely valid. I mean, you've got to take into account the fact that they are operating on a smaller amount of data, so it's not like you need these giant server systems and farms out there to process the local language capability, the small language models that are implementable. On the other hand, if you look at the kind of devices that are deployed in IoT, there's a huge range. The analysts are saying that even today, there are 25, 30 billion devices out there. How many of them are capable of using edge AI? Not yet a large number of those. It's just going to be a smaller amount. Even in our space, the cellular IoT is about 3.5, 4 billion devices out of that 30. So you can see that the kind of processing power that you might need to implement edge AI is definitely going to be impactful to the application. So if you have a low power device, you're not going to be able to necessarily do edge AI, but you could have a gateway. You could have upstream from that sensor or a small low power device, a gateway that has the power, the smarts, the processing ability to perhaps do more than just simple data gathering or sensors in a physical world that is then analyzing that data to take some action. So it is not just a matter of going all the way to the extreme edge. I think it's a matter of pulling back to where you can implement edge AI techniques and where you can implement security. I think those are the important points to be made.
Exactly. Even in what we're doing within the Intelligence Suite, we will have gateways that are handling all of the native protocols, doing the controls and the monitoring, everything of that nature. But then it will hand off, the workload of what we call the intelligence processor, which obviously is a high performance, large, megatop kind of processing unit that can then go and handle the models that are needed, to get the job done. The main thing you've got to watch there is, again, you're getting back into the challenges of latency, efficiency, security. All those challenges come out of the woodwork when you do that too. But absolutely, Z, I completely agree.
So for someone that's looking at AI, agentic AI, in the real world, they're doing pilots or POCs. What are some of the things that people are doing? Number one. Number two, what are some of the things that they're running into that maybe they didn't know before? Rony, I know you've been talking about physical AI and some of you're saying every conversation now is AI. Right? I'll start with you again. I think you're on mute, Rony.
Sorry. I think that in the POCs, the one thing that is overlooked is actually scale. And then the second thing is, and especially with the AI enabled devices. And the second thing is regulation. It's a lot more complex than it initially seems. And Zee was talking about the car industry. We've been working on like very future sort of 2030 models with some of the manufacturers, and it's very complex. The regulations are extremely complex. Most of the current operating models of AI in cars and stuff don't fit the regulation, and they won't fit the regulation in a year or two. And I guess somewhere they're in that gray area now, but I mean things will need to change on that. And the other thing I would say about it is the inference point and the cloud, and it's just not tied up yet. If you got physical AI and the inference, where's your inference point? Where are you downloading software updates? He was talking about software updates. And, where are you downloading? And I'll tell you the other thing that we're seeing in future models is that we're talking about, in most of the use cases that we've spoken to an enterprise, it's 20 times the amount of software update. So we're expecting 20 times the amount of data. Then, and it's exactly the number, by the way. That's exactly the number in two of the large use cases that we have. Expecting 20 times the amount of annual data to be downloaded to the device. So, suddenly connectivity is not a byproduct. I think, for us there, it's not taking us out of business.
Yeah.
Yeah, I'm going to agree with Rony about that one. I mean, our 110 million devices are generating somewhere in the order of 10 petabytes of data per month. That's a simple IoT application.
I know, that's
enormous, absolutely enormous. And I want to be careful about two other comments. If without AI, right, processing that data to take the actions for which the IoT application was designed, it's almost impossible nowadays, right? And if you're going to go and scale, if you're going to indeed increase that to the predictions that the analysts say within the next 5, 10, 15 years, we'll be in the billions of devices, smart devices, AI-capable devices, then we have to use these tools and techniques. It's a matter of getting there. It's not a matter of if. It's a matter of making sure that we can do it right. I want to be careful. Rony mentioned something which is very important, that the connectivity costs could escalate out of control. And indeed, the network performance could be problematic from a latency perspective if you're not careful. To add to that, and somebody mentioned the term data lakes, I want to make sure that we don't create data museums. Not original to me. I've heard this phrase from somebody else before. The value of the information is in the processing of it, whether it's done locally at the edge or it's done back at a server somewhere. That's where the value lies. One of our earliest applications in our company was a business and residential alarm company that said, if you don't give me the data within 15 seconds, well, it was a bit of an exaggeration there, don't bother giving me the data because it no longer has any value. And I think that's where the smarts of an edge AI system of making sure that the data is presented, processed in the right way for the application to be effective is going to make a lot of sense in the future. That's the bottom line.
Okay. Yeah. In fact, Zee, I think one thing I want to key on something you said that was kind of interesting. You said autonomy, right? and human intervention. Right? So as you know, we're all excited about agentic AI, but yeah, I can kind of see that, hey, maybe there's some things that we shouldn't be doing with agentic AI, right? That maybe humans need to get involved, or maybe there's not enough human intervention.
Yeah. We could go back to Jurassic Park. We were so focused, so figured out if we could do it. We never took the time to decide if we should do it.
Exactly. Yeah, and I think Ronnie's point about regulations are extremely important as well. Regulations exist for a reason, right? They're a necessary, I hate to use this word, but a necessary evil, which is that they're protecting people. And when you protect people, you're going to have to make sure that what you do has the appropriate compliance with those regulations, the appropriate legal connotations of those implications, the appropriate privacy and other compliance requirements that are we're being told the regulators absolutely are going to demand, not just the changes that have occurred in the IoT space. This is a big deal. When you look at what's happening with the EU CRA, for example, which is not just IoT, it goes beyond that. The implications for deploying product that meet the requirements are enormous, and the implications for how you repair a product that has been attacked by a malware or a breach of some kind, and and AI systems at the edge AI units at the edge are going to get smarter than ever. You have to make sure that you take all of that into account, which is why we developed one comment. I tend to be a little extreme, so bear with me when I say this. All devices are subject to attack, and the question is, have they been attacked? That's where we believe that monitoring is essential. You need to understand what the patterns, whether AI-based patterns at the edge or the patterns for the device performance in the network and beyond, meet the expectations. And if they don't, something is awry. All data that doesn't meet that pattern by definition is suspect, and you need to understand that. And so we put together a system, we call it the Aeris IoT Watchtower system, that has been very successfully deployed in finding information. We recently had one example of a customer who had deployed units in Australia, in the EU, in the Far East, and exactly the same attack had taken place on a significant number of those devices, which, not surprisingly, because it was in different networks, physical cellular networks, the operators wouldn't see, but we saw it and were able to line up the fact that, oh, this device has got a problem, or these set of devices in this application has got a problem, because we're seeing it in completely disparate networks.
Thank you. What, based on your experiences with agentic AI and just IoT in general, what are some of the lessons learned, for someone out there that says, I want to get started going? What are some of the things that you guys have seen? What are some of the best practices? John, I'll start with you.
Certainly. I mean, I think all of us see the pain points that our customers have experienced, and they AI is the new shiny object. They want to go deploy something with AI. Everyone wants to leverage it, but then when they start grappling with the realities of what's required, everything from an infrastructure, I think, Benson, you start out with that. That is such a key thing. If you don't have the infrastructure you need to focus on that. But you really kind of need to decide what it is you're trying to do. Are you focused at some kind of, anomaly or defect detection type of activity, as a starting point? Are you looking at something more complicated where you're going to be taking, many more parameters into account, for predictive maintenance or something like that? It really depends on charting a course, because AI is a journey. It's not something you do quickly. You kind of need to lay the groundwork to be able to get to that scalability. We used to laugh that Internet of Things is not the answer. It's Internet of Things. And so we know that if you don't do that planning and chart that course, it's going to probably fail, which is very sad. We see that happen a lot. And people will dive in, they'll hire head count, they'll bring sharp young talent in to write a lot of code. But then at the end of the day, they realize what they've created may be a nice demonstration or a nice prototype, but then the reality of rolling that out at scale and in a meaningful way that has the level of quality and the decisions that's needed, that's a different challenge. So I think that upfront planning is critical, and the infrastructure deployment is critical, laying the groundwork for that. That's my 2 cents. And we can get into a whole nother discussion about security and all that. It's another world too, but I'll hand it over to one of the other panelists.
Rony or Z?
Ronnie,
No, see,
go
you
for
go
it.
ahead. Yeah, go ahead.
No, I think I was just going to endorse what John said primarily. And I think the important point to be mentioned over here is that what used to be, you had an application, you had a great idea, you go out there and you deploy it. Wonderful. Today's world, you have to take regulations into account. And security regulations notwithstanding, the ability to update the device is fundamental. So I would reemphasize my comment about OTA. Carefully orchestrated OTA for your entire fleet of devices that are out there for an application. It's no longer 10,000, 20,000 devices. You may have millions of devices that need to be updated in different environments. Some are in Africa, some are in Europe, some are in Japan, and you just need to make sure that what you do to them meaningfully gets the update necessary to make sure that any security issue, or let alone a new update or a new feature, or getting the small language models updated in a timely way to work well is important. So I'll emphasize that as a practical example of what to do next.
No, I have to say I've agreed with everything everybody said, and so
Yeah,
that's it for me.
I gave a keynote at NIST about a month ago. We talked about the concept of cybersecurity and trust. Right? So in the world of agents, especially with agentic IoT, AI IoT, all of a sudden the concept of trust is significantly a different conversation. Right? It's no longer about cybersecurity. I know, from an IoT perspective, we talk about protecting the data, protecting the device, but now you've got a model's out there making decisions. Now, but you can attack the model, right? And the model's within the security perimeter. How do you guys see something like that? Is that something like in your world? Are people paying enough attention to that, or what are some of the considerations?
There, on my side, I've sort of recently come across that. A model's running what they call in order to secure them, they're running what they call the air gap, in somewhere that it's just not connected anywhere. But the decisions are sort of taken in the air gap, so they don't, that they can't get attacked. But I guess everything can be manipulated in some way or another. But there's definitely that, and there's a lot of, suddenly security. Look, Zaeem started with a security product a number of years ago with Aeris. IoT was really not something that was worrying anybody in security. Nobody paid any money for IoT security. Nobody wanted to pay for it, and nobody believed that it's going to be a problem. And why would anybody care if they, broke into my electricity meter? But suddenly it's a very big, very, very big issue. And, we don't want to see planes flying off the sky. We don't want to see things burning or people, medical devices going wrong. And now it's actually very critical, with physical AI, robots going crazy and smashing your house. I'm just sort of going through that, the worst case scenario of it. But, malicious is malicious. Doesn't matter what it is. It could be, if somebody's malicious, it's malicious. So suddenly there is a very big element in security. It's not like
it's massive.
And the security,
Yeah.
The way we're seeing this, and sorry, I just finished that. The way we're seeing this is that it has to be baked into the network. We're talking about, we're doing millions of billions of events per day on the network all across the world. And I think there's only maybe 1 or 2 countries in the world where there's no active SIM. And there's, I can't explain, the amount of data that's coming out of there. It has to be baked into the network. There's no, doing it in external product or external companies. We feel it has to be baked into the network. It has to be consumed by our customers to enrich their models. They have a model, they have a product, their product is out there in the field, it's doing something. But the connectivity data that is generated, whether it's generated specifically for their devices or from our entire network, anonymized, is there to enrich their product and to be used as a security product as well. So to be used as security features. Anomaly detection, what Zaeem was talking about, is a very good example of that. Where suddenly a device shows up once it's in London and 5 minutes later it's in Ukraine, then it's a problem. Then you have a problem. It didn't get there by itself. So these are sort of things that they have to be baked into the network.
Absolutely, and that just to interject one other comment, which is that we're still in the early learning phase about what AI can do for us at the edge, let alone beyond the edge in the network itself. I think we will see some amazing things happen, but at the same time, we may have some learning experiences that don't quite meet our expectations for what we thought would happen, which is fine. We have to evolve and learn where we get to with the use of AI, not only at the edge, but within the network. And it is a powerful tool. We use it internally in our company. We've been doing machine learning for more than 13, 14, 15 years on what used to be control plane data. And now we've gone beyond that to our customers are doing it for their actual data that they're gathering at the edge.
Yeah, and I think to add to what you said, it almost has to be addressed. The context of security has to be addressed at every level. The network is critical, absolutely, but within the touch points where you're connecting to a physical device, most of those protocols don't have a security context built into them. And one easy way to game a system is to send corrupted data into it to cause something to fail, and then what do you do when it fails? Do you recover? Do you stop? All of those. So these kind of things are the types of things we're going to have to be thinking through. That in the past, we just worried about connecting the dots end to end and getting the data where it needed to go as quickly and as reliably as we could. Now that's all true, but now we've got to be much more intelligent about how we protect it and get it there. So,
Thank you, John. We've gone over time a little bit, so I wanted to close out the webinar session with one final quick question. For someone that's starting or thinking of starting an Agentic AI IoT project, what practical advice would you give them?
Who do you want to go first? I'll take a stab at that, which is that find the right experts to help you, because it is a learning curve involved if you're not familiar with what AI can do for you, let alone what edge AI could do for you at an IoT device. Find the right experts, and any one of our companies would be one of the people that I would go to if I was out there making a product to say, how would I get this done? Don't go it alone.
I'd say don't go it alone, but take your time too.
Right.
Have a well thought out plan. Don't be in a rush to see something immediately, because you don't know what you don't know until you get into it. And that's just the whole. I think Agentic by definition is like observe, reason, act, and learn. Right? You kind of got this continuous process, but you need to do that in the physical implementation of it as well, because you're going to learn things you didn't know, and you're going to have to make course corrections.
Yeah, I would say start in phases, start small, and it's moving fast. Things that we thought 6 months ago are pretty historical now, and it's just suddenly so. Always to sort of take that into consideration as well. It's don't invest in something that you can't upgrade and you can't move with and you don't have the infrastructure for. We said the word infrastructure several times today. If you don't have the right infrastructure, everything's great when you're doing sort of a POC, a test, a trial, but build the right infrastructure. For me, that's pretty much everything, because you're going to have faster models and more, and you're going to need some memory on there, and you're going to need some idea how to manage it, and it's going to move fast. So so take your time. Thinking fast and slow. That doesn't mind either.
That's great. I'll leave with this. I think number one is pick the right project. I think it's very easy to get over ambitious. I think we all mentioned infrastructure. It's very it's not uncommon to do a pilot and then realize you didn't really have the data pipeline or data infrastructure to support it from an operational perspective. Number two, I think I heard Z you say, right, the human part of it. So there's the governance part of it. Make sure that you put it in the right places, right? Into the operations. There's a human in the loop. Right? Not everything needs to be completely autonomous, right? But do it intelligently. I know people get excited about, hey, agentic AI and automation. It can do all these things, but maybe they're putting too much trust into it at this point. But especially with physical AI, right? You're asking a lot. And humans need to be involved. You need to make sure you have good data and make sure your models are well trained and have access to that data. So I think that's a part that's kind of overlooked. So with that, I want to thank all of you for your time today. Thank you for the audience. I know we ran over. If you have any questions, please put them up and we'll answer them afterwards. David, I'm going to turn it back over to you. Thank you again, everyone.
Thank you, Benson, and thank you to our panelists as well as to our audience. It was a great discussion today, and we'd like you to check out our website and look for upcoming events that are coming out and more exciting things to come. So thank you all. Have a nice day.
Thank you.
Thank you.
Thank you.
Thank you.